And we're live now. All right. Hey, welcome to Virtual Brown Bag. This is April 26th.
That's
So if you
right.
don't know what it is, go to virtualbrownbag.com, get the info. Generally, it's the idea came from Claudio and me after a user, or I guess a conference. We were like, hey, we enjoyed chatting, and it was great that we can share ideas and tools and tips. And but the problem is that sometimes you don't work in a place where that it can happen, or you're remote, or you're just like a one-man shop, and you don't. It's hard getting that sort of conversation and going. So we're like, hey, let's just have a virtual brand bag online where people can come in, share what they've been reading, what they've been learning, any tools are cool, and new frameworks. And so that was the birth of it. And we did it for, I guess, many years, and then
Yeah.
that we moved away from different tech stacks, and we had some difficulty doing online meetings. And this year we decided to bring it back and do Google Hangouts and get back to sharing all our stuff. We were all C sharp, and now we're all everything else, like everywhere and everything, and still some
That's
C sharp
right.
in there too. But
Yeah.
yeah, so today I think we're going to lead off with Andy, who's been, I guess, semi-regular, if not regular, attendee and part of the new generation of virtual bag friends and network. And he's going to go through a presentation where he did, I guess, a project using Cycle.js. And then, of course, as he goes through, we'll be asking questions. And you know me, I'm going to be wanting to look at code and then ask all sorts of crazy questions about code. But that's enough blabbing for me. How about Andy? What's handed off to you?
Yeah, thank you. So the topic for today is functional reactive programming with Cycle.js. I aim at providing a very light introduction, as well as demonstrating what's special or different about Cycle.js compared to other frameworks. My name is Andy Mallet. I have over 13 years of experience in software development, mostly Ruby and Java, as well as a lot of JavaScript more recently. Let's delve into it. Uh, as a quick introduction, Cycle.js came out in 2015 out of the work of André Stoltz. He's a Brazilian guy who actually moved to Finland and works at Futuris, one of the, I guess, best employment satisfaction companies in Europe. And out of his work there came out Cycle.js, which is an idea that really was trying to improve upon React. So he actually is a fan of that fact that React made functional programming in the forefront of JavaScript development by having people, develop components as pure functions that render changes to a virtual DOM. And he's taking the idea further and saying, okay, why stop there? Why not go full functional? Have truly functional, not just style of programming, but also like style of persistence. So he borrows ideas from Haskell's functional language with regards to how to manage side effects, whether it's making DOM changes on the screen, reading data from a data store, etc. So let's delve more into that. So I'll be covering like a very brief intro to reactive programming, talk about Cycle.js, the philosophies behind it, provide a very quick tutorial, some examples, and a few extras at the end, like things to check out after the talk. So let's get started. The Reactive Manifesto came out a few years ago, which was trying to emphasize the fact that software is moving in the reactive direction, and most software now are desirable for having these attributes: being responsive, resilient, message-driven, and elastic. And I think a lot of the emphasis in reactive is message-driven. So I would say elastic, responsive, resilient is something that was important regardless with enterprise software. But message-driven is becoming more emphasized, whether it's just messages between JavaScript processes on the browser, or whether it's just general like backend message-driven. So it's the idea of reacting to events, basically. Uh, One of the libraries that help provide reactive programming constructs is RxJS, and it's actually the library that is used in Cycle.js for the reactive part. One of the key challenges with pure functional programming is you don't want to have mutations, you don't want to mutate states, you don't want to cause side effects. So then what do you do? Well, one way of thinking about the problem is every change you cause happens on the time continuum, or like on the time, on the axis of time. So meaning, in a way, you didn't really change something. You created a new version of something with a new time slot. So for example, like my hand was here right now, it's here right now, 2 seconds later, or whatever, 1 second later. So a second ago, my hand was here. Again, if you go back forward in time, my hand is here now. So if you capture data in that way, you're always creating snapshots of data along the axis of time. And then you could just work with different versions of the data that you have without having changed the data. You've actually added more data. So in a way, this introduces the idea of streams, data streams. So in a way, everything could be thought of as a data stream. And RxJS provides you with a whole bunch of libraries that allow you to perform operations on data streams. And we'll see more examples as we go along. So one quick visual example, though, is think of a user clicking on the screen, and every time they click the mouse, there's going to be a click stream that generates the coordinates of that click, as well as maybe what element it clicked. So in this is going to generate a click event stream, which is again moving along the axis of time. But then you can actually introduce functional programming to the mix and like process this data with a function. So for example, throttle the click stream to only no more than an event every 250 milliseconds. So if I clicked 5 times, like very quick, it'll only capture 1 every 250 milliseconds. That can be helpful for certain scenarios. Buffering, if you want to like somehow improve performance or affect performance. So this produces then a new stream of data. Once you have the new stream of data, you can then perform another function and map that data into the length of the list, for example. And then, so the length started as 1, and then it became 2, and etc. And then you can filter on it, and then you can finally do something with the final data. This example is not very concrete, so I'm sorry if it doesn't make a lot of sense. But I'm trying to demonstrate functional reactor programming in the sense that you always work with a stream, you operate on it, and then you produce a final result. And again, I'll be showing real concrete examples in a moment. Before I get there, though, let's talk about CycleJS. So CycleJS is trying to build on top of that and say, okay, if we can process anything with a function, starting with a stream, we can think of the entire computer or computer program as just one big function then that takes input from the user and gives output back. And then if you put it on the axis of time, there's always input coming in and output coming out, input coming in, output coming out. So that's like a dialogue kind of function between human and computer. Which, when I first heard the idea in André Steltz's presentation that I saw on YouTube from last year, I thought it was very interesting how simplified that whole problem of computing became when you think of it that way. It became so simple that, like, in theory, you should be able to just write one function and then decompose it to focus it on different parts in order to solve any problem, really. Which is something I heard about from Clojure programmers in the past that have worked with when I was at Groupon.com. Not with directly on projects, but alongside what I meant. I did Ruby on Rails at Groupon for a while, but I had some Clojure colleagues that were big fans of this idea. So let's go further into it. So again, one way of thinking about it is the computer will always receive input, process it with a function, and then give the user back output. So what that means is they could be receiving mouse clicks, keyboard presses, etc., and then processing HTML onto the screen. Again, in a way, the user himself you could think of the user as a function because they have their own senses that are their own input. So it's whatever the user sees on the screen, whatever they touch with their hand on the mouse, the keyboard, tactile senses, etc. But then the actuators are the actions that they take, such as like a mouse click or a keyboard press, etc. So I mean, to go even deeper, the sources of data could be keyboard, mouse, or other even system events. And then you would do some processing on it with like one main function. So that's the CycleJS way of doing things. And you always receive data as a sort of sources, because the source, you could have multiple sources of data for the computer. So it could be timed events coming from cron. It could be web events coming from some web call, or it could even be user input from a keyboard, from mouse, or multiple pieces of hardware. Finally, though, once the work is done, it has to sync it somewhere, so it actually returns the syncs. So this is the simplified way of thinking about computer programs in general that CycleJS actually implements in JavaScript. And as far as syncs, in a web setting with JavaScript, like you would think of them as DOM effects in the browser, HTTP effects as in making web request calls, and finally some other effects, any sorts of other effects, like storing data in the local HTML data store or cookies, etc. So is everything clear so far?
Yeah, like sources and syncs also is beyond just this scenario or even just JavaScript. These are like computer concepts and programming concepts that we actually expand a little more onto Elixir land too, because the latest new stuff are focusing a lot on this and making this process easier to do and manage, because of course it's functional, and that format of input output and sources and syncs and so forth is just sort of a overarching concept, I guess I'll bring in. It's more than just one example in CycleJS or whatever. So,
and if I'm not mistaken, Elixir is the language that's built on top of JavaScript. Is that right?
No, the Elixir is built on top of Erlang VM.
My bad. That was a different one. Sorry, I mixed them up. Do you remember what the other one was?
They have Elixir script is what we had one guy, Brian, come in and share, and that built on top of JavaScript, but it's giving the Elixir syntax inside there. I'm trying to figure out something else.
There is one other language that's built on top of JavaScript, and it actually borrows Haskell concepts, and part of CycleJS is inspired by it as well. Elixir. So never mind though. Elixir, is also a functional language based. I've heard of it. I've never toyed with it though. Yep.
Yeah, I just remember Elixir Comp. It was one of the big things. It's not. I'm not sure if it's the next version or the version after that, but it was a significant amount of time was spent in the keynote and in some other talks discussing sources and syncs and how they were getting some things wrong and how they're going to make some things easier and better. And so it was just funny seeing that, and I was like, yeah, this is becoming more and more of a thing. Just
Interesting. It's becoming more and more of a, kind of like how object-oriented programming came out, say, in the 80s or 70s, even before then, but it started becoming more and more a thing in the 80s, I guess, till it became mainstream in the 90s. Nowadays, I hear more and more functional programming coming back, even though it's one of the oldest paradigms. So I'll move on. To explain things a bit in more detail or to summarize what I just talked about. Again, a Cycle app is nothing but a continuous dialogue between a human and a computer. Computer is represented as one decomposable function that you can then make it as modular as you'd like. And there's even patterns that the CycleJS creator recommends, which I'll go over. There's one main pattern. Input is handled by mouse, keyboard, time events. Output is DOM, HTTP, other effects. And the philosophies behind CycleJS are, being functional and reactive, simple and concise, extensible and testable. So given that you write everything as a function, they're supposed to be easier to test, especially that they don't maintain state. You always pass input and get output back, so that makes them very easily testable. According to them, that's something I have not toyed with. I meant to toy with yesterday, and I didn't get a chance to do a lot of work. But I could cover maybe in another time in a 10-minute quick talk or something. Explicit data flow, which is given that it's functional, you always see the data coming into every function coming out of it. And then composable, so functions are composable by nature. You can compose functions, make the input of a function another function, or the output of it feed it into another function. So we'll see examples of that. Now, as far as let's delve into CycleJS. What does CycleJS consist of? It's actually 4 main parts right now. There's the cycle core, which is the runtime that wires everything together. There's the cycle DOM driver, which allows you to do things like receive inputs from the DOM. And then there's the HTTP driver, which allows you to perform web requests. And then there's RxJS. So the core allows you to build that main function that I talked about earlier, and then it provides you with source drivers. So any side effects need to be offloaded with drivers in the Cycle.js universe, so that you don't have to think of them yourself. You just write your code as pure functions. So yeah, so you can use source drivers, and it's very highly. There's a very good ecosystem for Cycle.js right now with a lot of drivers, and then there's also sync drivers. So source drivers, kind of like the DOM driver that lets you monitor DOM events. So think of it as like the jQuery equivalent. And then sync drivers are, there's the HTTP one that lets you perform web requests. And then there's the HTML driver, which lets you render HTML. And one interesting thing about Cycle.js is, given that Andrea was a bit of a fan of React, he actually just pretty much reused virtual DOM in Cycle.js. So it does rely on virtual DOM in the HTML driver. So Cycle DOM, again, DOM driver, HTML driver, which is a JS DSL for HTML on top of the virtual DOM. So one of the philosophies here is to keep things in one language and not split into multiple languages. However, Cycle.js does have a driver for JSX if somebody's interested in using JSX. So if anybody's converting from React, it's a very simple conversion, and you end up with less code usually, because React is functional, but it's got this object glorification around the function, where Cycle.js is just the function. And we'll go over code examples in a moment. Syntax. So I mean, this is HyperScript, which is their alternative to JSX, which is in pure JavaScript, and it's a bit simpler than what the React original syntax for it was. So it becomes practical in a sense, and you can keep it in, and then you can stay in one language, just in JavaScript. So you have, BR, so you can do it like this, div, and you can give it like an ID, P, you can give it an ID, a bunch of other attributes, and then the content, and then finally a div, and if you have multiple elements, it's the contents you pass it as an array at the end. So again, the API of this is just ID class, attributes, and then content / or children. So content could be just pure text, or children is just an array. So I mean, it's just a quick tutorial of how this works before I delve into real examples of it, just to give you a bit of a background. So let's move on. Oh yeah, this is a quick comparison of HyperScript and pure JavaScript versus JSX. It's just showing how it's a bit terser, as well as a bit more readable, a bit easier to read than the mixing of paradigms that JSX does. However, both options are available. I personally have been toying a lot with HyperScript because I like the fact that I stay in JavaScript, but I've tried JSX as well, and it works just as well. Cycle HTTP driver source and sync supports. Ajax. Okay, so this one actually is a sort of a source and sync driver. I may have listed it as sync before, but it's actually both, because when you make an Ajax request, that's a sync. You're syncing an output from your function that's saying, okay, in this time slot, like at 12 o'clock, like at noon, whatever, send an Ajax request right now. But then at like 12:01, we get the response. So a later iteration in time, you get the response as a source data instead of sync data. So and you'll see that in the example soon. RxJS, I mean, reiterate our things about RxJS, provides DOM event support, which is used in the DOM driver, so you don't have to deal with it directly. Aggregation so the rest is aggregation operators, join calculus, things like think kind of like map reduce, that kind of stuff. Observables, promise support, time scheduling, throttling. Okay, I think I've talked enough. Let me just jump into an example, and then I'll come back to a few of the things I haven't covered. So let's jump into hello time. So I mean, again, what is the equivalent of like the simplest thing you could do with reactive programming, or like functional reactive programming? So like beyond hello world, because hello world doesn't have any time element in it. Well, hello time is just the simple idea of showing hello with 0 seconds elapsed, but as then the program will keep elapsing time second by second. You'll see that the times change until it hits 7 seconds, and then it hits 18 seconds, etc. So so again, if we were to break this down into a function, before I proceed to the next screen, what do you guys think are the sources of this main function?
So you mentioned the timeline stuff, but I mean, I guess would be, do you need recording mouse events or just the time? Like every second goes by?
Well, you're right. You're right. Time exactly. So what is that source? What would you call it?
I don't know, time.
Okay, you know what? No, I like your answer because it's very abstract. Because it's better if you start abstract before you even look at the code, because then you come up with a simple solution, and then you could like. But yeah, as far as code though, RxJS gives you timed events, so it's a timed events basically. What else?
I would expect it to be like every second, since that's what we care about.
Absolutely.
Like an event would pop up and we would respond to it.
Okay, and then output is. We know the output is HTML, so we agree about that. So let's jump into the code. So this is it. This is the program. Again, so we have a main function. The source, you have source drivers and then destination or sync drivers or syncs. But let's actually the syncs are not necessarily drivers, but they rely on drivers to build themselves. Well, let's go over it bit by bit. So as far as the main function, it's receiving drivers as the source. So then we go here and it needs the DOM also as a source in order to make modifications to it. I just remember, or in order to send new changes to it. So DOM, you need a DOM driver, and then cycle, which is the cycle core, will actually run and wire the drivers in main in a sort of a cycle, a continuous cycle of a dialog. And then once that happens, then here, once we dig into main, the first thing we're going to start with is a time source. So we say Rx observable interval, every 1,000 milliseconds. I'd like you to map an I, which starts from 0, and then 1, 2, 3, etc., and then return a hash that is basically just I plus 1. So, like in this case, it's going to be the second that you're on. So like 1, 2, 3, 4, and then finally we're going to build the syncs that are going to be the output of this function. So this is just going to be a hash again. And if you're making DOM effects, the Cycle.js way is you would use a key called DOM. So you would use a key representing whatever changes you're making. If it's a web request, it would be HTTP. If it's like DOM, it would be DOM. And then you start with this input, and then you map every point in time into a message. You map it into a DOM elements using Hyperscript, where the message that comes in from the time source is actually this I. So it's going to be 1, 2, 3. So like 1 second, 2 second, 3 second. And then here it's just a simple, kind of like JSX. It's just a simple, like div, H1, H2. And then it uses the time key that we put over here. And then it prints it out to the screen. And then finally return the syncs. So this should give us exactly what we needed. So then if we go back here, it's going to print, hello, and then 18 seconds elapsed. So I've been
Can you
using.
go back to the code, Andy, real quick? So So the first line, I'm looking at 8 to 9. The reason we're doing I plus 1, and I'm just going to talk that out, and you can say right, wrong, is because this is going to pop an event every second. And the I that I'm getting in this scenario is the index. And so the first one's going to be 0. So when the first second passes by, it's going to pop 1. It's going to be 0. And I really wanted to say 1. So I'm adding 1 there.
Not only that, you're also building a data structure. So we built here a hash, like a hash of time key pointing to that value.
Right. And so the return of what I get in line 9, that hash or that JSON object that you put there, in section with the DOM with the time source, that's what the message is, right? The message is going to be what I put up there in that time thing.
Yes.
And that's why in line 14 I'm saying, hey, give me the time property.
Yes. Yep.
Now you said there's the DOM. Like, does that have to be DOM, or could I have two different? Could I call it something else?
As far as I know, no. It has to be DOM. That's a signal for you to let Cycle.js know it's a DOM. I'm not sure. I never tried to call it something else, but in all of their examples, they call it DOM. You might be right. Maybe they don't care because maybe they figure out that this is a DOM driver anyways from the object type and whatever, and they will operate on it correctly regardless, whatever technique, whether it's polymorphism or whatever. But as far as I know, the standard is we would call it DOM here and here.
Because I was thinking, like, if you had two different like plugins, you could reference them two different things.
So you would have DOM, and then you would have HTTP. Yeah. You would need different keys for sure. That's a very good question. I really don't have the answer because I've never experimented with switching DOM itself to something else, though. I'll play around with it, but I don't know. That's a good question. Okay. Let's go into a more elaborate example. So, I mean, suppose we have two sources. Well, I already gave it away, but yeah, we have two sources here in a way of input. We have the time events, but we also have the user type text. So, or you could think of it as user events, because every time you type a key, the key itself is sort of the input event. So, I could type a word here. So let's just say you start with the screen saying anonymous. It says, hello, anonymous, 0 seconds elapsed. You go here, and then, 9 seconds elapsed. But then you change the name, the word. It maintains the time. So the key is it shouldn't reset the time or lose it. It should continue, so it's 14 seconds, and S, then Sean, 32 seconds. So again, this one is a bit more elaborate example. So we're going to have, so these are not really syncs. Think of them as streams or sources. That was a typo, but here basically we're going to start with an initial. So when you say Rx observable of, you're saying this is my initial state. So it's going to have time 0 and name anonymous. We're going to have a time stream then that basically will emit a data structure with time 1 just like before every second, and then next we're going to have another stream, which is the user click or user type stream, which is basically drivers DOM. So we're going to use the DOM driver, select name. So this is kind of like a jQuery kind of thing, except it produces a stream instead of what jQuery would give you. And then events, give me a stream of all events that are key up, meaning every time I type on the keyboard and I lift my finger up. And then finally, once it finishes, it maps the stream of every event into the value of the key that was typed. And then finally, it returns, oh, no, actually, this is different. This is the value of the element that was pressed. So in this case, it's going to be the full word. So it could be Sean, for example. And then here, it takes that Sean, and then it puts it in a data structure. Because again, going back, functional style programming, you need a data structure of sort to manipulate. And I mean, I could manipulate a raw value, but it's nicer when it's like this. So and finally, there's this thing called message. Let's just call it message stream that basically will merge them all together. So this is the issue with what do you do when you have multiple streams of data coming at different times? So they're not all coming at the same time. Like at like 12, like at 1 second that. It just said anonymous for the text. So in fact, there was no user events for the text field at 1 second. It wasn't until 9 seconds that we had the user type the letter S. And then when they typed the letter S, we got the letter S, let's just say at 9.5 seconds. It wasn't even at the same time. So what do you do when you have different things coming at different times? So this is the part that takes practice to master. And this is what I find most interesting about CycleJS style programming and reactive functional programming, is because to me that's a brand new skill. Kind of like when I learned object-oriented design 10 years ago or 12 years ago, and I had to master design patterns and coming up with the proper abstractions and how do you do loose coupling and high cohesion, all these things. Here it's like different way. Like functional reactive programming, it's like mastering the idea of thinking of things as streams, merging them in your head. So I'm having to learn new mental models of things. I have to picture streams, merge them in my head, and see how you manipulate them in order to produce the output, which is the final stream that you're going to work with in order to do your work. So in this case, we're going to start with this as the first point on the stream. It has time 0, name anonymous, and then we're going to merge the time stream into it, and then merge the name stream. And so at different times, we'll get points in time that will either give us a new time value or a new name value. Think of it that way. Finally, that's not enough though, because if you do this, then once we get a new time value, you're only going to get this data structure. And if you get this data structure, the name will get erased. Meaning, if I were to go here, and it says 9 seconds anonymous, and then I type S, but then more time elapses, the S gets deleted. Like we go back to just hello, and then it says 15 seconds elapsed. However, to account for this issue, we need to actually merge them, and in order to merge them, we can use something called scan, which is kind of like reduce, except the different. It's the reduce of streams basically. So reduce lets you reduce a finite set of data, whereas scan lets you do that on an infinite set of data. So basically, it says, okay, always give me the previous value and the current value, and then let's just say the current value is only this one. So it says, okay, take the name from the previous one and put it as the actual name, and then take the time from the current value and put it as the actual time. Whereas if it was a user event, then it's going to take the name that was typed last from the user, but then take the time from the previous event. So that way you always are merging your data so that the last point of data in the stream is one that encompasses both name and time. So again, this is I'm sorry if it's hard to explain, but it's a skill that takes a while to get used to. For somebody coming from an object-oriented background, sorry, for somebody coming from a functional background, it's like basic stuff. Anyways, so finally, what we do is we sync this into, we use this in the sync because we're going to map it in the end into the DOM structure, the virtual DOM. And this is where we use here at one point message name. So we say hello, Sean, and then we use the time. So it says like 14 seconds elapsed, and then it finally syncs it. So yeah. Any questions?
No, I kind of like the merge thing. Makes sense. I'm going to do a little aside here. So if you come from the outside looking in with this stuff, you can look at it and be like, hey, this seems kind of complex with the stream. So what would you say is the advantage to you, for your perspective, of thinking this way? Because you're right, you're saying, hey, it's a different way of approaching it. What have you been like, hey, this is a little bit challenging, but what have you had any moments where you're like, man, this made this so much easier, or this so much better, or this was totally worth it, or how do you view it?
Okay, so I regret to inform you that I'm not a pro on functional programming or FRP, unfortunately. So I'm presenting something that I thought was cool, and it's an open source project. However, I do know that I heard a lot from hardcore functional programming fans that the reason they like this is it offloads side effects. They like streams because streams offload side effects and allow you to do pure functional programming, because then the final function is always pure. You always here just receive data and then you operate on it. You never mutate. So here there's no logic that's saying take the name from a jQuery event and merge it into some data structure here and then use it in the UI, which is something something you do sometimes in React programming. You read from the state. Well, it depends on what form of React programming you're doing. If you're using Flux, I guess you wouldn't do it, or Redux. But if you're doing standard, it's a bit of an object-oriented state management code. So to get rid of that, you do everything as streams, and then there's no side effects. Everything's happening on a stream, and you always here end up receiving pure data. I would say that's my understanding of why you would do this.
Yeah, you could definitely make it where your rendering is definitely separate, and like you always can test what it should render based on the data that you come in.
Exactly. So in the end, each one of those is one function that can be split off and tested independently. Like each one of these could be thought of as something independent. And I'll show you an example later of an app where I actually do split them off in the app. So
it's interesting to approach. I'm extrapolating with the idea that if you have an HTTP sync, that is sort of an interesting approach. That those are just events as well. They're syncs and sources. So like when someone clicks on this stuff, you send out. Like you're listening to it, and instead of rendering a DOM element, you send an HTTP request. And on the same event, when you get a response back, instead of like handling inside your own view, that's just another event that you're responding to. And I guess different people behave differently based on what that response will be.
Yeah, exactly. And it takes a bit of creativity to get used to that mindset, and that's the part that I find fun about it. That's why I find CycleJS fun. It reminds me exactly of the same excitement I had like 15 years ago when I was learning object-oriented programming, because object-oriented programming or paradigm was a bit new compared to just structured programming before it. By the way, functional programming is not the same as structured programming. They're very different. So they have some similarities, but they're very different. So just to clarify that, structured programming doesn't care about side effects. You can have side effects in it. Still, it just doesn't have objects. So, anyways, I find the challenge of like the same challenge I had with coming up with objects is the challenge I'm coming up with how to come up with streams and manage streams. So let's go into a more involved example now. Let's just say we have a really like a real hardcore example where actually you're going to build this app that will give you a layout for conference rooms in an office, and then lets you visually book them by just clicking on the room that doesn't have a color. So imagine the room that's white is free. You click it and you book it, and you enter time somewhere. Like say I want to book it for an hour. Then you click it and it books. And then as time is moving along, it actually will start decoloring till it becomes white again. So it becomes brown, and then as time moves along, it becomes white again. So I mean, so this program is a lot more interesting because it's visual. It has a lot more complicated UI. It uses SVG actually. It's going to need SVG for this, and so it'll show you how you could use SVG with HyperScript as well. And it'll involve time events as well as user events. So let's as well as HTTP requests as well, because I'm going to be hitting the database to request the room names. Ideally, I would request the room layout too, but in my first version of this program, it's very simple. I have a basic room that doesn't change. So let's now look at some example. Can you guys all see the screen?
Mm-hmm.
My browser? Okay. So this is, let's imagine an office that has the conference rooms named after countries. Every company has its own naming scheme. So let's just say, France, England, Canada, Germany, Japan, United States. And then here I say, okay, I want to book it for 30 seconds, or like I could type, So let's just say I type something like 22 seconds, and I press Canada, so it becomes green. But then you can see it decoloring, and then this thing also becomes a sink instead of a source. So it was a source when I typed into it, and now it's a sink of data that's showing us the time as it's elapsing. And then here, this is the sink of data as well, because it's showing us the color changing as time is changing. So I mean, this is quite the involved example. Like if you can solve this, my hope from building this was if I could solve this, then I could solve any problem in CycleJS.
And I will speak to having done with different frameworks handling source of time. This is actually an appealing approach because normally we're handling events like when they click this and click that, but approaching it all from as a stream of events simplifies a lot of complexity with stuff like, like to me, we had one with the idle timeout. Like if someone is idle, for so long, you need to do something. With different frameworks, that problem is complex. And even when I was doing the daily fantasy stuff too, you had there's a timeout, like after a certain event, like certain time, they can't do anything anymore, like the contest is locked. That in Angular and in Knockout and stuff like that, it was more complicated. And here, it's just run of the mill. It's just another event, no big deal, And so having that timer. So while this looks simple and it is a simple idea, it's pretty powerful with that. The complexity that I've seen so far is the complexity is that now in handling human inputs is weirder than you're used to. But with the benefit is that all of it becomes everything is one flow and everything is one process.
Yeah. The weirdness is in the merging of the data,
and
not necessarily in solving the problem or writing the
right. It's thinking of it. Yeah, it's a brain twist. Once you think about it this way, it's not as complex.
Yeah. I mean, again, I'm new to it myself, so I've been doing it only for 3 months, I think. Or a bit more, but yeah, hopefully the promise of what you were saying is true. Only time will tell, but let me open a program. So let me open the program. Let's take a quick look at it. Perhaps I could put it on the right side. This. Perfect. Okay, yeah, this is good. So this is built with Ruby on Rails as the backend. and the front end is obviously JavaScript with ES6. So let's take a quick look at the code. So the way I divided it was something I came up with. It wasn't necessarily recommended by them. They prescribe you a pattern, for which I also followed, but they don't give you necessarily an organization scheme. So I came up with this one that seemed to make sense. It's if you have a source, functions that produce a source of data, put it under source. If it produces the final sink of data, put it under sink. And then finally, you can have cycles, which is functions that do both. And then the main function is under main ES6. So the extension is ES6 instead of JS, just because of some preprocessor I'm using that needs that extension. So again, if we look at the data, that's it. This is the entire program, and that's the power of this CycleJS approach. I mean, I don't want to say CycleJS because the idea is older than CycleJS. It's just the idea of thinking of the entire program as a function. Indeed, it is one decomposable function, and it's really simple. It's just, you take the input drivers, so that's part of the input, and then you have a view model cycle. So the way I modeled it was I borrowed some concepts from object-oriented modeling. So except they're functions in this case. So this is a function called view model cycle, which will take the drivers and give me a view model data structure, and then here I'll actually use. Oh yeah, and then this one actually will contain, given that this is a cycle, this will have both a cycle source and a cycle sink. So I'll actually use the source and pass it again to another function called main view, which will render the main view of this entire thing, and then give me the DOM sink. And then also I'll take the sink from this thing and use it. I happen to know that it's HTTP, so I'm using it as HTTP. And that was just one way I wrote this program. I'm sure there's improvements to the way it's written, but bear with me, please, guys. So drivers, right now I only need 2 drivers. I need the DOM driver, which will convert the app element in the app into a CycleJS app. So anything outside of that element can be just standard Rails HTML stuff, but once you hit this element, so you could put body. I've written programs where I put body, meaning everything is within the CycleJS scope. It's nice to have that option, and then here HTTP. So now let's dig a bit deeper into it. Like, what does view model cycle do? What does main view do? I mean, this one is obviously just showing us rendering the main view. This one, we have no idea what it does. So let's go and, I mean, it's a view model. So this is saying all the logic and intelligence of this view is in here. So let's go and dig into that next. So I'm trying to show you, I'll demonstrate how you would maintain a program like this. Like if I come back later and I need to maintain it, that's the process I would follow. So I would go here. So actually, I mean, we can read here. View model cycle is cycles, models, view models. So we go into cycles, and that itself is divided. So I have HTTP cycles and model cycles, depending on what it's doing. So this one, let me see if I can make this a bit bigger so it's easier to see both. Okay. I just need the whole screen. Okay. So this is gonna be, again, taking the drivers and passing them to room request cycle function and produce me a room request. So I've abstracted away any room request details, but I'm saying give me request all request the room that I need. Let's dig more into it. Okay, here it's saying return a data structure where the cycle source is RX observable combined latest from the cycle source of the room request, as well as the booked room timing source, which will give me data related to once I book a room. Now I have a booked room timing source. So that's the way I broke the problem down. Is the data structure is a booked room timing source, which consists of the time that's elapsing, the name of the room that's booked, and that might be it. So again, we'll dig more into it as we go along. And by the way, I presented this talk a while ago, but I did not prepare before today's presentation much because I was curious to see how I could re-maintain this code. So I'm showing you the weakness and the strength right now of the code. So I'm sorry about this, but yeah. So let's dig now into what room request does. So this one, I mean, this is basically merging the data using combined latest instead of scan, which is an alternative to a simpler alternative to scan for special cases. It'll basically always say take the last two snapshots from between now and between these two streams. Sorry, combine the latest two snapshots between these two streams. So it does exactly what I was doing with scan earlier, except this is shorter syntax. And finally, it gives me a room request cycle sync because it's gonna request room data from, let me see, cycle sync. Yeah, so this is gonna send a room request. Well, let's dig there. Okay, so this is coming from room request cycle, which is coming from, there we go, coming from here. Okay, now we're having some stuff that's a lot less abstract and more easier to understand. So this one is, okay, so we got drivers, HTTP. It's got something kind of like the fetch framework, so it lets you be able to see. So, okay, so here it's making a room request using the drivers that were passed to it, and then once it gets the room, it's filtering the data, merging all, mapping the response, and then finally building from the response the room's data structure, and then returning it. And I'm sorry, I don't remember what this exactly was doing, but let me. Oh yeah, I do remember now. When you have HTTP drivers, they might have different kinds of requests. So here I'm picking exactly the request I need, which is for the room's URL, and only that's the one that I care about its data. The rest I don't care about them. So the thing about the stream world is everything is always running and happening. You just have to pick and choose what you need from the data and work with it. So you could almost, like, if I had 10 requests for 10 different URLs, they're all going to be happening, but I'm going to be requesting only the one I care about, like filtering the list by that one. And I just copied this code from Cycle's website. They just do it that way, and then I do this. Finally, it just gives me, yeah. So it finally, so the Cycle source is going to be the data that we get back, which is the room's information, and then the sync is the request itself, which was the way you request in Cycles. You have to follow this format where you just give them the URL. Okay, so we go back here now, and we look at booked room timing source, which is probably one of the more interesting things in this project. So this one will actually start with the defaults and then merge into them. So I have this merge sources thing, that's a shortcut function that will basically merge the defaults with the book duration source, so the duration as it's elapsing. Or no, sorry, this is the booking duration. This is 22 seconds. That's the initial value the user entered. This is the time as it's elapsing, time change source, and then room booking source, which is which room got booked. So once we have those 3 streams or 4 streams, we merge them all, and then the bulk of the work for this one is actually in scan, where I actually grab the booked room, the duration, the time, and based on those, so those 4 things are all in one function because they all because this function they interact all together in order for you to find the final result. But the final result that we care about is at every second we want to know what the time was, what the booked room was, and what the original duration was that we wanted. So duration would be 22 seconds, time would be 10, 9, 8, 7 as it's moving along, and finally the booked room could be Canada in this case.
Does this work with multiple? Can you book multiple rooms? Am I just not?
Well, you could if you want, but my requirements right now is just 1 room at a time.
Okay.
Eventually we will support multiple rooms, but right now I think it interrupts it. I actually intentionally have it restart,
Gotcha.
which was my initial implementation. It was intentional. It wasn't a bug. But yeah, absolutely. In the future, it has to be multiple rooms. Okay, so I think we're running out of time, so let me delve into other components. So default source, let's look into that. So that's coming from streams, default source. So this just gives me the initial defaults of the program, like the time was 60 seconds, or booked room. Yeah, duration was 60 seconds when we started. booked room was nothing, room none. So that's that. Time change source is the one that's the RxJS time thing. It's just this thing. So nothing special about that. Again, so I'll go back here. Booking duration source. Let's look at that one. Okay, so that one is the one where duration is the text field. So it's this text field where I can type something and then click room. So this one, in this case, is this duration element on key up. Give me the duration and then build this data structure of duration and time. So you're always working with like tiny sources of data and then producing tiny sinks of data in every one of those components. And then finally, it's kind of like pipes and filters. Like you basically have multiple sources and you have to sync them at one point. And then time change source, yeah, is another source. But then finally, once you get to room timing source, this is kind of like a merge sync of sort, because this one will end up then processing those four and doing stuff with them. But again, this itself also might get merged into some other function that will merge it with other things. So everything is always like you have source data, you do some work, and then you output data. The key about it is you have to keep every element as simple as possible and as focused as possible when it needs. So this one only cares about those four because it needs to do some work that will have them affect each other. I don't want to delve into this work because it's a bit has a long story behind it, but let me, it's better to show you more stuff first before I get back if I had extra time. So view model cycle. Okay, so here, this is another example where we took the entire booked room timing source that was merging a bunch of things, and we're merging it again, combining it again with room request info. And then this thing finally gets fed into main view, which will get the message that was produced from the previous thing. So it'll get the message that has time, booked room, duration, as well as room request info, and then feed them into, this is showing you how easy it is to maintain the view part. So you just have a div, you have a booking view, a floor plan view. That's it, which is exactly what we see on the screen. So as far as maintenance of the view, it's very simple with Hyperscript. Like this is the main, it's just like HTML really, or JSX. Like this is the top part, booking view, and then this is floor plan view. That's it. Except here there are functions. So again, booking view is very static. Like it just has this H1, please enter duration needed to book a room by clicking on it. H2, the input field for duration. It might be doing a bit of logic, just like React JSX usually does some logic in it. And then finally, it shows the name of the booked room. So again, this is kind of like I click here. So this is the top part, and like this part, the input field, and then this is the booked room name, and it's all coming from this message. And this message is also used to deduce if time was elapsing based on whether the time is different from duration. If duration is 11 and time is 11, then there's no time elapsing. But the moment they diverge, we know there's elapsing. So based on that, then we could block off the field. So let me show you. So if I click Germany, this field is blocked off now. I can't do anything with it anymore. It's disabled. So that was done here. There we go. Elapsed, disabled. And then the value, if it's time elapsing, then use the time. Otherwise, just use the source duration. Okay. And the final and most interesting part is the floor plan. How do we do that? So that one is SVG. The nice thing about they give you actually HTML to Hyperscript converters online, where you can convert any HTML to Hyperscript and back if you need to. So I actually just took an SVG for a floor plan and dropped it in that thing, and it converted it to this Hyperscript. So this is all Hyperscript syntax that was given to me based on that SVG document, and I just plugged it in and then added the dynamic parts to it. So room opacity, so here we calculate room opacity. So again, everything is a pure function. We get input, data, so based on the booked room and the time and duration, I calculate the room opacity, which is how dark it is, etc. And then here, room offset is something. Yeah, this is just me trying to modify the placement of the text for the rooms. This doesn't matter as much. This is just this is the key part. So then, how do we use room opacity? So it's, there you go. For each one of those elements is representing one of those rooms. So yeah, there we go. And it actually will use a function again, and based on the index of that room, it'll calculate the opacity for that room and then render it on the screen. And that's pretty much it. There's not much more to that, I think. So finally, I mean, we have only 3 minutes left, but if I were to go back to booked room time source, which is the bulk of where the logic happens, this one was, let's read it. So it's reading the time, it's reading the booked room, it's reading the duration. Then if booked room is not none, and we have time change, then the time. Okay, so this is dealing with the issue that. Okay, let's look at time change source. Right, this gives us a delta. So delta doesn't tell you what the time is, so that's why here I have to calculate the time based on it. So I produce it based on time change by altering time, but I only do that if there is time change and if no room is there. Or okay, if no room is there, then I do it one way, but then once we have a room, I do it a different way. So yeah, again, I'm not going to delve too much into this logic, but this is where the bulk of the logic happens. It's really not that complicated. Like,
even if it is slightly complicated,
it's very simple code, and you can test it. Function. It's very simple to test. It's very short. It's a very short function, really. It's just like 5-6 lines of logic, and then this is just the data structure. There's not much to it. Oh yeah, and this is just merging stuff. Yeah, I think this is it. I mean, there was one more thing, which was the room request. Oh no, I already showed you that. Yeah, this is it. Any questions?
No, I mean, it's an interesting approach. Probably want to get hands-on, and maybe we have another day where we just code from ground up some cycle stuff. I got a project going, and it works, and so it'll be where we can launch from, and I'll work on something that problem set that we can solve, because I think as we code it, I think more clarity comes through, because I've done thinking this way, so sometimes it's easier for me to connect the dots on some stuff. But one thing I was thinking about is like although there's a stream of events, and that stream of events is input, then it creates this output. There's no like, is there a state anywhere? Like, is there a place where you can record the current state of the app, or would that just be some sort of?
I think RxJS keeps it, because RxJS keeps. I think it lets you do time traveling too, if I'm not mistaken. It keeps the stream forever, if I'm not mistaken. Like, meaning every step that happened back in time is recorded by RxJS outside of your program, so it's offloaded from you. So you'd have to use RxJS methods to do things through their way in order to get access to it. That's my understanding. Don't hold me to my answer, though, because I haven't tried it. That's my understanding.
Yeah, that's something.
However, in your program, in my program, there's no state, whatsoever. Yeah. There's none, actually.
Well, that's one thing, Claudio, would be cool to mess around with, is that we worked on a project together where we ended up doing so it was doing some cognitive behavior testing, and so it's one of the things you have to test is how fast people respond to things, and so there's a heavy time component to that. I'd be curious to try taking one of those elements of that test and like do this in Cycle.js and see what the results would be, because I would think we would be able to get a clear data set that, the goal would be if you can get a clear data set and then be able to reproduce it and process it and see what it would look like inside Cycle.js.
Yep, that would be fun.
Because it was all about like how fast can you respond to these things? When did they click on this, and was it the right click? Because the way we would test it would be we were trying to test whether we were concussed or messed up, and so sometimes you would drink a lot so that your response time would be delayed. And before you think, wow, you're a bunch of drunkards, I've talked to other people who've done similar projects, and that is the way to QA test it. So if you're looking for a good QA time, test cognitive tests and get drunk, and and then watch as your response times are crap.
To go back to your question about state,
yeah.
Regarding how it would fit into your program, the one you just mentioned. So one thing to keep in mind, you could still have state, except state is always offloaded with drivers. So for example, state could be you sending a request to a server to store the data in an API. That's one way. Another way is you would have a local HTML store driver, and you would use the HTML, like the web store, basically, the local store. But it also happens to a driver. So you would send a sync to it, and you would get a source back later. You would never actually store in your app store the state directly. Like you just write functions, and then the drivers do the any side effects or non-pure modifications happen in drivers.
Yeah, let's do that. And Claudia, I'll coordinate with you and figure out which section we would do, and it'd just be fun to code it and just see what we can do with it. Because this is the type of thing that will I use Cycle.js necessarily in my next project? Probably not, because I like React Redux and they're perfectly fine. But the time spent in here is time well spent, because it's going to be thinking about the problem in a different way and seeing what the results come back, and taking what we learn from here and applying it to our other frameworks and stuff that we've been doing. This is the whole point of all the stuff that we do with the brown bag and learning other programming languages and other frameworks. The point isn't necessarily that you have to switch from Ruby to Python to the stuff because Python is better or anything. The point is you can learn to code Python, and stuff that the way you think about that problem you can apply to your Ruby code or your C# code and be a better programmer. Anyway.
Agreed.
Recommended links. Sorry, I don't know if you guys see them. Like this YouTube video is highly recommended.
I will point out too, the guy was from Brazil, so that gave him some bonus points.
That's right.
But then in your conference rooms, you didn't have Brazil as a conference room, so that you lost points there. Because
I can't win it all.
Claudia would be like, I don't want any of these rooms. They're inferior.
That's right.
You didn't even have Portugal, so they could at least be like Portuguese brothers and unite.
Correct.
Well, I don't know. Brazil is an entire floor. That's why it's not there.
Oh, that's it.
I see.
That's right. Okay, fair enough.
Right.
That one is always booked by the CEO. Sorry, it's not. It's off track. Of course.
Yeah.
Not for the mere mortals.
Yeah. Andy is great. Thank you for taking the time and walking through this. And let's see. We'll schedule something in the future where we can do some more pairing on this thing, because I dabbled with it and I want to get more into it. Because walking through the code is one thing. Trying to code it is something else. And sometimes things like this, it's so helpful to have a guide, a little code Sherpa to let you know what you're doing wrong.
Sure, definitely.
All right, guys. Well, that'll be it for this week. Next week, we'll see what other topics we'll have, but I still have my React Redux testing stuff on standby. I'll probably do a little more work on that, and we'll dive more into the testing side of it and things. And of course, you know me, that it's not going to be a lot of talking. It's going to be a lot of coding. So walking through the code, we'll learn to test some stuff and see why I like React Redux and how easy it is to test. And show a little Webpack too, because that's a bit of insanity that once you get it right, you don't want to mess with it. All right, guys. Talk to y'all later.
All right. Bye, everybody.